Good morning, everyone. Thank you for joining us. We will get started here in a few minutes, just letting everyone join and get settled. Appreciate seeing you all on a Friday morning. Looking like a lovely morning out there. So hopefully you have your coffee and are ready to hear a little more about what we've all been going through with the new stretch code. Also, we will paste the CUs in the chat, and if you haven't gotten a notice, this is being recorded. So please just take note. It will be up on the BSA's website under the COTE and codes site. So you'll be able to share it out later on. We'll just give ourselves a few minutes to get settled and get everyone in. And then we'll get started. For those of you that are just joining, we're just getting settled in. We should be up and running here in a minute. If you are just joining, the CUs will be posted. If that is something that you need, we will get that in the chat. We will try to take questions at the end. We've saved time, so have questions at the end. So if you can put those in the chat as they come up as we go through. But and then we'll try to do our best to answer the presentations, but we'll definitely have time at the end. So it is just after 9, and appreciate you all joining us so early. Well, maybe not so early. Let's joining us on a Friday morning. And we really are excited to once again talk with everyone about the stretch code. We know that our last talk on the stretch code was very well attended, and we appreciate all the feedback and we appreciate everyone's interest. So we have continued this as a series, as we noted, and really diving into existing buildings is what we're here to talk about today, because we know that that is on a lot of folks' minds, both with residential and commercial. So if everyone is ready, I will start as we go. So just a note, as I said, this is a series. It's being put on by the BSA groups. I am the co-chair, I'm Laura Fod, I'm the co-chair of the COTE, the Committee on the Environment, the BSA COTE group, with Beth Piercy, who's also on, and Megan Carrier, the co-chair for the codes group, is also sponsoring it. We are also greatly supported by the Sustainable Design Leaders group for Boston and numbers of other folks who are all dealing with this. And so we appreciate everyone's time and effort. So as I said, we had the overview discussion back in January, our first of the series, and we are now at the existing buildings. And we will be continuing our talk next month with a discussion on TEDI, which I know is exciting and on everyone's mind. And then moving on to HERS talk, and then a BEC enclosure, and then commercial and residential. Residential got off the screen, but it's to come. So moving through today's talk, we will be touching again on the compliance pathways, the existing residential compliance, with a little bit of discussion about the HERS and how we're implementing, then the existing commercial compliance and a case study of how we're going through that. And then we're going to talk about some additional considerations, the other things that we all have to keep in mind as we move through this. And then, as I mentioned, we will have time at the end for questions. We know that we're all working through this, and so we want this to be a discussion. We want to talk with you all about it. So who is here today? All of these lovely folks are here. Myself, Lauren Gunther from DeMillo Schaefer, Sunny Dillard from HMFH, Kim Lazar from WSP, Patrick Murphy from Vanderweil, Chris Mazzulla from Home Energy Raiders, and Nick Falkoff. Sorry, Nick. I just knew I'd do that, from Auburndale Builders. So we've got a really great group of folks who can answer questions, who can take, who are working through this themselves. But I'm going to say, premise this all is that we're not code specialists. We are just engineers and architects and builders and raters who are working through this. So we are doing exactly what you all are doing. We're in the trenches just trying to figure it out. And we are excited about the code. We are really interested in what it's doing to move us all forward, but we're still digging through it too. So please bear with us. We are not necessarily experts, just folks trying to do our best. So walking through the compliance pathway, I think we've all seen this. If you have watched the previous discussion, our overview, you'll recognize numbers of it, but just in case, we wanted to touch on it quickly. This is all of our Massachusetts municipalities. As you can see, we as a state are very much stretch code. There are 49 towns, municipalities that are not, they're still in base code, but the majority of 297 are stretch code. We do have our specialized codes that have opted in as of a couple weeks ago. Brookline, Cambridge, Newton, Somerville, and Watertown are all specialized code, and that will be coming into effect either July 1st or January 1st, depending on the time frame that they were adopted. As just really another way of looking at that, we have multiple codes in place in our state. We have the IECC as our general base code with the mass amendments. In Massachusetts, we always have those mass amendments. And if you are not a stretch code community, if you're part of those if you're working in one of those 49 communities, then you are in that base code, just the IECC with mass amendments. After that, you then move into stretch code communities, the majority of our state, and then the specialized opt-in code, as we talked about, just those few communities that have already been able to pass that. Again, another way of looking at that, because there's timelines overlaid on top of all of this. We have the, as we knew, the technical guidance came back out in December from the DOER, which was great. It gave us a view of what was coming. And then January 1 or beginning of January, the residential folks kicked in with that specialized code, or with that stretch code. And then we will be seeing in July 1, the commercial stretch code will kick in. And so we'll start to really take effect for all permitting projects after that. And as we mentioned, the opt-in code will kick in January 1, or for those few communities that got in time in July 1. And then we also have the lowered values, that escalating values for HERS rating that will also take into effect in the following year. So I will hand this over to Lauren to start us on our path.
Thanks, Laura. Excited to be here. So over the last 3 months, members of the Sustainable Design Leaders group in Boston, so Sunny Dillard of HMFH, Diane Tufts of PCA, and Gabriel Aitchison of ICON, and myself, Lauren Gunter of DeMillo Schaefer, developed these decision trees which help to navigate you through the updated energy code. Our group has also had very lively discussions with the DOER, Paul Armand and Ian Finlayson, who have helped to provide feedback on these decision trees. So it's important to note that our group focused on looking at the code language specifically, and we tried not to interpret one way or the other. We just tried to really focus in on what the code is saying. So these decision trees have led to many conversations where we've talked about various applications to help understand the updated energy code. And hopefully there will be further clarification in the DOER's technical guidance at some point. So here we are starting with the main existing construction decision tree, which leads you either into the low-rise residential or the commercial / multifamily. If we can go back. Oh, sorry, thanks. So the first question is your project a residential use? If no, then that puts you straight into the existing construction commercial or commercial tree. If it is a yes, then that kicks you into, is your project 3 stories or less? If no, again, then if your project is 4 stories or more, then that puts you into the existing construction commercial / multifamily. If yes, your project is 3 stories or less, that puts you into existing construction low-rise residential. So I'm going to talk about the existing low-rise residential branch, and Sunny will present the existing commercial and multifamily branch. And throughout the presentation, we pepper in these fun facts. And so this one first pertains to the specialized opt-in code. And we do provide references throughout these decision trees to kind of show you where we have gotten this language. So this specialized opt-in code pertains to new buildings only. And as we talk about the decision trees on the next few slides, this is an important distinction for low-rise residential and commercial existing construction. So next slide, please. So we're going to get into the existing buildings low-rise residential decision tree. So here is the overall low-rise residential tree. And I don't know if you can hit some of the space bar. Sorry, I forgot to coordinate that. So the first question first leads you to determine if your project location is in a stretch code community. If your project is not a stretch code community, then you'll follow the base energy code, which is IECC 2021 with MA amendments. If yes, your building is within a stretch code community, then it will take you into the stretch energy code, define your scope of improvements. So I'll first be talking about repairs, change of occupancy or use, and alterations. And then lastly, if you just do spacebar, sorry, I'll be talking about additions. Okay, and on the next slide here, throughout our discussions, we have felt it helpful to provide additional layer of information in addition to these decision trees. And we've been calling them fun facts. So this is the first time the stretch code applies to existing alterations, change of use or occupancy, and additions. In the previous energy code, it was under the base energy code, and now it's within the stretch code. So level, sorry, I'll go to additions, alterations, and change of use or occupancy each have different requirements. So if your building has an addition and an alteration, then compliance is required for each portion. So it's each portion has to comply with the requirements for that specific update to that building. Lastly, levels of alteration are applicable to the decision tree for the low-rise residential existing construction energy code requirements. And this is a big distinction between the existing low-rise and the existing commercial, which Sunny will elaborate further when she talks about that. So the next few slides are going to focus on repairs, change of occupancy or use, alterations. And so another distinction between low-rise residential and commercial energy code is that low-rise residential has this extra middle layer of questions, which then lead you into yes or no buckets. Another item to point out is the reference to dwelling unit. A dwelling unit provides accommodation for living, sleeping, eating, cooking, and sanitation. So if it's maybe, for instance, a dormitory that's 3 stories or less, that only has sleeping units and not a bathroom or kitchen within that dormitory room, then the HERS requirement wouldn't apply. So it's important to understand that as I go through. So if we go to the next slide, please. Thanks. So this, I'm going to just separate it out. So first talking about repairs. If your project only has scope limited to maintenance or correcting damage, then you would fall into this repairs bucket, which then leads you to section R504. And so I'm going to also touch upon historic towards the end. So under each of these kind of separate paths, you'll see a question, about historic, which I'll touch upon in the last slide. So I'm going to change of occupancy or use. Is your project changing from one use group to another or use within a group? Then that is considered a change of occupancy or use. So then the question is the change of use greater than 1,000 square feet? If no, then you comply with the prescriptive requirements under R505. If yes, then you comply with the prescriptive requirements and R406.5. This is the HERS index score located within that table R406.5. And the maximum would be 5255, depending on if your project is mixed fueled or all electric. So HERS, again, is just for the dwelling unit. So then getting into alteration, an alteration applies to non-conditioned space converted to conditioned space where envelope dimensions are unaltered. So for instance, if you have an existing unconditioned basement where the existing basement walls are already existing, and you decide to convert that to conditioned basement, then that is an alteration. So this is an important distinction between alteration and addition. In that sense, when you don't increase the existing envelope surface area, then that is an alteration. So next question, is the project a level 3 alteration exceeding 1,000 square feet or 100% of the conditioned floor area? So level 3 alteration applies where the work is equal to or greater than 50% of the building area. So again, Sunny will touch upon how that is different in the existing commercial code. So the CFA or conditioned floor area is the floor surface connected to the building thermal envelope. So if no to that question, then you comply with the prescriptive requirements under section R503. And then if yes, then you comply with prescriptive and HERS 5255 for the dwelling unit. So here we have the addition tree. So an addition is added conditioned floor space not within the existing building. So for instance, if you're proposing to raise the entire roof. This is actually a question that came up in our discussions. If you're proposing to raise the entire roof, which changes the roof line, then this would be an addition because you're increasing the envelope area and building a new roof. So then the next question is the addition to a dwelling unit greater than or equal to 1,000 square feet, or does it exceed the existing conditioned floor area? So if no, then comply with prescriptive requirements under section R502.3. And then if yes, you comply with prescriptive and HERS 5255. So another item to note is that if new envelope assemblies in additions of less than 1,000 square feet are, they would be then exempt from air leakage testing. So that's another good point. And then an addition fulfills the requirements of this code where the addition alone complies, or where the existing building and addition comply as one building, or where the existing building with the addition meets the HERS index score 5255. So lastly here, looking at historic. So the historic energy code language can be found in section R 501.6, and it applies to repairs, change of occupancy or use, or alterations. So those are the three ones where it could apply. And historic buildings are not exempt from the energy code, though code officials may provide waivers for specific requirements within the code, and cannot be met because they are proven that they could destroy the historic nature of the building. So I know there's probably a lot of questions about what that all means, and we can certainly, open that up at the, after we go through this to discuss further. One thing I wanted to know that I forgot to mention is the specialized opt-in code does not apply to low-rise residential additions, whereas when Sunny talks about the commercial code, you'll see where that is a difference there. So thanks.
Oh, this is our part. All right, well, thank you. My name's Chris Mazzola. I'm with Home Energy Raiders. I'm here with Nick from Auburndale Builders. We have 3 slides, so we'll try to get through them quickly. So which of the, so in the HERS models, we want to just give you a brief overview, and I guess we'll dig into this later in the series, but for single family builders and architects, who are going to be, or typically home builders and architects will fill out their or request their HERS modeling around the time of permitting. We want to get that process started at the conceptual stages. And Nick always loves to use the description of different dials. So what are the dials that matter most? So typically we like to start off with orientation of the building, and there's multiple benefits to orientating the building properly for eventually or possible solar PV arrays, for orientation of the glazing, and how that those glazing performances affect the HERS score. Windows are the weakest point in your thermal envelope. So the better the window, the less impact they will have. A high solar heat gain is great for our climate zone 5, in the marine 4s. U values, we want to be low. So ideally, just for an example, like a 0.14 U value and a 0.41 solar heat gain is a good window. That's a great window for our climate zone. Orientation always affects PV, and PV has a few different benefits in the HERS modeling now. One, it increases your HERS score by 5 points. It allows you to model to a HERS 58. But it also significantly reduces your HERS score because our modeling software looks at kilowatt usage, and that's really how the algorithms come up with that HERS score, that number. We also, look at the differences between triple glazed windows and double glazed windows and the benefits of both. Cost engineering wise, double is always cheaper. But depending on the situation and the location of the building and the height of the building, triple glaze may have other requirements and needs for the building. The fourth kind of dial is always mechanicals. And we always talk about, what's the expectation of the homeowners and the architect and the designer and the builder, and what type of fuel do we really want to use? If there's an expectation of the homeowner that they really want a 6-burner gas stove, then we do our best to model these with gas. I would think obviously all electric buildings score better. Air source heat pumps, ground source heat pumps do have a much higher efficiency rate. And when you combine that all electric house with solar, you get, you know, essentially a zero energy home. So it's the expectation that's important. You know, any fuel type in any house can be made to pass. It's just what's the expectations, and knowing that the state of Massachusetts does have a decarbonization goal for 2030 and for 2050, getting your builders used to this all electric home now is probably a good idea. Just kind of baby steps. I'm a big baby step kind of guy. So I like to, you know, what are the incremental steps we need to make today and for maybe the next 14 months in preparation for the next code change and this next HERS score drop. You know, the envelope is always, I think, probably what people focus on. And the envelope is important. It is important. And how we design those assemblies is important. And Nick's going to get into some of the reasons, the building science reasons why, but our code is so strict, and it's been so strict for so long. And our infiltration rate, the tightness of our buildings has been so strict for so long that there isn't a lot of savings. There isn't a lot of HERS score improvements we can make until we get to really, really robust above grade walls. You know, the base code is an R60 in a roof or an attic. That's a pretty robust assembly. So we're really looking for minimizing the thermal bridging. So making sure your builders are using insulated headers, limiting jack and king studs, and using open corners and ladder bracing, looking at, you know, more innovative products like T-studs or engineered studding, you know, TJIs, looking for something with a lower thermal breaks. And then, you know, air tightness, you know, getting that blower door test down to, you know, somewhere close to 3 ACH. The 2021 IECC is a 5 ACH. It actually went up because the HERS scores went down. And houses are just tight. You know, so that's, you know, there's different ways of getting to that air tightness. So this is our transition slide. So I'm going to hand it all over to Nick. He's going to talk about some building science stuff, but essentially this, there's one screen on the left is an Ecotrope glazing screen. And it just kind of shows you, you know, we want to limit the amount of glazing we have. We want to maximize the orientation of that glazing. We're looking for low U values and looking for high solar heat gains. And that's, you know, one of the biggest dials to get to 55, 52s, 45s, 42s. And then eventually the HERS negative threes. So hand it over to Nick. Thank you, everyone.
Thanks. Next slide, please. Thanks. So I'm Nick Felkoff with Auburndale Builders, and we've been building all electric passive homes for a number of years. And I'm working with Chris in the New England, with the Northeast HERS Radio Association to develop a course. So we're working on a 4-part course right now, which will dig more into each of these dials. And what we're doing is Chris's team is modeling live while we're talking, and we're trying out different dials. And I'm coming from a passive house perspective where I'm used to architects or energy modelers modeling WUFI, and WUFI does hydrothermal analysis, and I'm used to like the passive house vapor, like looking at where the moisture is moving in the walls. And so it's interesting to see, we used to exceed our HERS numbers by so much I never really looked at them. But now that the HERS numbers are getting tighter and passive house is an alternate route, I'm sort of looking at what's the difference. So one thing that I'm seeing is that wall insulation, you want to watch out. If you start to dial up an existing building's insulation, you really want to look. The Ecotrope software does not do hygrothermal analysis, and you want to look at where is your dew point in your walls. So if you're trading off in the dials and you say I have to bring a whole building up to or down to a HERS 42 or 45, just be careful with watch your R value. So I put a link to Green Building Advisor. That's just something I'm seeing. Roof insulation is the same thing. You know, if we start with an R60 roof, if you take an existing roof and start to dial it way up, pay close attention to your ventilation and possible vapor diffusion ports. Green Building Advisor has a number of good articles on that as well. And then same with air tightness. So if you have an existing building and you're adding on an addition, and that addition triggers that you have to bring the whole building down to like a tighter envelope, really think about what it is you're locking into that existing building. So you know, paying closer attention to radon, paying closer attention to your moisture sources, other indoor pollutants, and then also looking at ventilation. So Chris and I have been talking about, you know, how do you size your ERVs and looking at like, how do you ventilate the existing building? So there's a lot of dials. There's obviously working on a 300-year-old house or a 20-year-old house, two different things. And so in the 4-part course we're working on, we'll sort of look at different dials and look at different options. So this is just our early findings as we're looking at the models together. Thank you.
All right, so now we're going to move away from residential and into the existing commercial compliance paths. Lauren gave a great intro to our process and how we were working through this and who's helped with it. But if we're here, you've decided that your project is not residential. And we're going to start by defining the scope of improvements, starting with repair, change of use or occupancy, and alterations. And we've grouped those together because they're generally in the prescriptive compliance paths. And then I'll talk a little bit about the additions. Going through some of the requirements of each, but reading through the appropriate scopes within the code and discussing with the AHJ is the best way to confirm the appropriate path. So I just want to make sure that we keep honing in on that. Go ahead and go to the next slide. But let's start with some fun facts. This is the first time the stretch code applies to alterations, change of occupancy or use, and additions of all sizes. So that's similar to the low-rise residential. And then all scopes have different requirements. So if a project fits into multiple scopes, the compliance is required for each portion. Example, if you have a renovation and addition, you'd have to comply with both of the different scope paths. Like Lauren said, unlike residential energy code, the commercial code does not look at level of alterations as a guidance for compliance. So we'll walk you through what that means in the next slides. So in each of the next few slides, there's a little decipher at the top right for these code sections, because these existing building code sections point you back toward new code language. So that's important to remember that all of these sections will point you back to the new stretch code. And I'll just go through them really quickly, but this will be the only time. C401.3 is guidance for the thermal envelope certificate. C402 are the envelope requirements. So those are like the R and U values for roof slab, walls, fenestration. And then C403 through 405 cover the MEP requirements. C406 are all those fun tables of additional efficiency requirements that are covered by project type. And then C408 is maintenance and commissioning. Go ahead and go to the next slide. I'm going to start with repairs. So this is basically like maintenance and corrective damage. And in commercial code, this section directs you back to C501.3 and C501.4, which basically states that repairs should comply with the code in which the building was constructed, provided that this does not create hazards to life, health, or property. So that one's pretty self-explanatory. And as Lauren stated, I will cover some of the historic components, but they're pretty similar at the end. Next slide. Change of use or occupancy, which is C505. This is a prescriptive compliance, and the intent is not to require energy modeling. for a lot of the existing buildings, though some of the paths that they talk about will lead you to using energy modeling, but the guidance is really trying to make everything prescriptive for existing buildings. So rule of thumb for change of use or occupancy that we've been sort of saying is if you touch it, you have to upgrade it, but that actually doesn't apply for change of use or occupancy. This scope applies to the entire building. So if your building changes use or occupancy, you need to upgrade the entire building. And that reference is in the new code envelope, MEP, maintenance and commissioning sections. And then unlike change of use, the alterations only apply to the altered component. So this one, if you touch it, you do have to upgrade it. And it encompasses the non-conditioned spaces converted to conditioned spaces where envelope dimensions are unaltered or not increased. So that's sort of the major difference between change of use or occupancy and alteration. And then again, it goes through the different prescriptive compliance paths like C402, which are the thermal envelope requirements, and then MEP. Go to the next slide. I just want to note that with change of use and occupancy and alterations, there are alternate compliance paths other than the prescriptive compliance path. So on the side here, you see that we've got 2 additional compliance paths that will require energy modeling. And it's usually having to deal with a less stringent envelope. Historic. What does it mean if you're working a historic structure? So similar to the previous code compliance, in that a project team can prove that specific measures would degrade or conflict with the historic nature of the building and request a waiver from the code officials. And the intent is really to upgrade when you can. We don't want to destroy the historic nature of our communities. And so this is really hoping that you'll work with the authorities having jurisdiction and your and the folks that are helping you to upgrade your envelopes. So upgrade it if you can, and then if you can't, then talk to your code officials to get a waiver from that. Finally, additions. So there are actually a couple more questions in this one. Is the addition greater than 20,000 square feet or greater than 100% of the size of the existing building? So this is non-conditioned to conditioned where the envelope dimensions have changed. So if you answer no to that question, it drops you right down to prescriptive compliance. And that's the new code sections that are the envelope, MEP, and commissioning sections. And the additional efficiency requirements. If you've answered yes to this question, fun fact, the addition is treated like new construction. So I'm not going to go through the entire new construction branches, but to get you to the right path, there are a few more questions. And the first is this project a residential building and greater than or equal to 4 stories? So basically this is asking, is this a multifamily project? If yes, you go to the commercial energy code that covers mid to high rise multifamily, which is 4 stories or greater. If you answer no, then there's one more question. Is your building's ventilation rate greater than 0.5 CFM per square foot, or is it less than 0.5 CFM per square foot? Yes or no, that puts you into big buildings, low vent, or big buildings, high vent. And as Laura said, we'll go through these paths at a later date, but that'll sort of get you to the right bucket. And I also want to note that an addition can show code compliance if the addition alone complies, or if the existing building and the addition comply as a single building. So the commercial branch is a little bit more, a little bit easier to run through, and Laura's going to walk us through an example now.
Thanks, Sunny. Because I'm a visual human and I learn from example, and I think a number of us do, these decision trees are great to get us to that point, but then we wanted to just walk you through quickly through how we're doing it. So this is a project that I'm working on that it will be under the stretch code. It is a existing historic, as you can see from the photo, building of about 24,000 square feet. It will have an addition of around 9,000 square feet. It's currently a 4-story building with it's wood framed with brick facing. We're in climate zone 5. It will be a public space. It's a historic neighborhood, but not a listed building. And it's had some recent work, redone windows, solar on the roof, and it has some high sustainability goals. And they'd like to consider geothermal. So just a bit of its program. So what does that mean, taking us through the decision tree? It has an addition, but so that's already kicking me into the addition path. Is that addition greater than 20,000 square feet? No, so I get to take the chute or ladder, I guess chute, down to the prescriptive compliance path. So I just am going to quickly walk you through the means that I walk through with this prescriptive path, and I'm going to focus on the envelope requirements because I'm an architect and you don't want me to play mechanical engineer or any other discipline. But I will note that for the additional thermal envelope certificate is relatively straightforward, but for the other aspects of this, the other 4 aspects, go back and listen to the overview talk we had in January. It goes into good depth on those, and it'll give you a great, hopefully answer any questions. And then if you have further questions, come to the next talk. So as I noted, just walking through those envelope requirements, and as Sunny noted too, these are those breakdowns of what happens for each section, and then further breakdowns of the C402. We get into the R values. So these are our envelope requirements. Reading through an attic space code. These are the weighted values. So, the roof for attic is, comes out to about an R47 if you were doing that portion. And so we would be insulating within our existing, and then obviously at the addition as well. The walls themselves, above grade walls from the prescriptive from the code requirements for wood framed are about an R40. So we would be, because of the historic nature, insulating to the interior, and of course, going greater at our addition. I will note here too that this, not for this project, but for another project we're looking at, we are looking at this exception. So there is this exception for existing buildings, the existing buildings section of the code, the 500s, notes that there are a few exceptions for alterations because, working on this building is the alteration, not the addition. And number 4 is construction where the existing roof, wall, or floor cavity is not exposed. We are exempt. We read that as being exempted from meeting those values. So, if you weren't taking the plaster off these walls, that is how we read that. And we are, would like to have further conversations with our AHJ and the DOER, but I believe, that is something that we should be looking at and how we treat. But moving through this building is not how we would be working through that. So walls below grade are 8, and below slab are 2. But again, the alterations, we are not affecting the existing slab. So we're not, we read that as without requiring the unaltered portions of the existing building. So we are not touching the below grade slab, the below grade walls. We would still be insulating to the interior of those walls. But as is noted, we look at dew point in any of these scenarios. We'll be doing dew point and WFI analysis of those existing walls to make sure that we're hitting a level that would not be causing issues to the existing structure. And then the 402.3 is the solar readiness, which is also addressed in the Appendix CB. We actually have the lovely aspect of this project is that the roof has recently been replaced with new solar on it. So we are not needing to worry about that, but on our addition, we would obviously be solar ready. And then fenestration, as I noted, the windows in this building were recently renovated, but they will not meet the U values and the solar heat gain coefficient values of the new code. So we will be needing to address those throughout the building. And kind of that separate fun fact again is that, you know, again, not on this building, but another project that we're looking at the same time, there is an exception in that existing building's alteration that as long, and I should note that I don't think I said it the previous, that as long as we're not increasing the energy use of the building, that is a key to any of these exceptions, no increase of energy use, which sounds so maybe surprising that you would even think that you would increase energy use, but often these buildings were not air conditioned. So if you're adding air conditioning, that could be a trigger taking you over. So just putting that disclaimer out there, as long as we're still reducing our energy use, which we hope we all are, you have an exemption for adding storm windows and not triggering in the window upgrades. So then another big one for us is air leakage, and how do you lower, decrease our air leakage, increase our air leakage rate, for meeting this, creating a whole air barrier. It's obviously a tough detailing once we get to existing buildings, but addressing that. And again, exemptions if for the is not recover or not required for roof recover or replacement if the other portions of the building were not being renovated. So I know that was a very quick version of a case study, but it's just to start to think about how do we implement these pieces. So I'm sure we'll have questions, and I know folks have been asking in the chat, so we appreciate that. But now I'll hand it over to Kim to take us through some more additional considerations.
Thank you, Laura. So just in general, the rule of thumb for existing building alterations is, if you touch it, you have to upgrade it. And, those upgrades have a lot of implications on your building, as we've kind of touched on. And so on the, the next slide, if we just quickly kind of run through some of these, energy improvements that wouldn't require further upgrades. And so I know Laura touched upon a couple of these in her example. And, the addition of storm windows, you can apply surface films on single pane glazing, roof recover, but you don't necessarily need the air barrier. And then again, you can do like an overclad or just addition of interior insulation if you do not expose, wall or roof floor cavities. But what I really want to focus on is the last one, where the proposed UA is not greater than 110% of the target. So if you go to the next slide, we can see what those targets are. And so they're different between a low glaze and high glaze building. So these are the adjusted values for that 110% from what the new construction code is. And this is the only exception of that list that is different from what the base code has. And it's important to note that while it might seem like a great idea to kind of strive to use this exception, to use that increased 110% of the target, this only allows, the UA factor only allows for a increased U factor of the opaque walls. It does not allow a different fenestration factor. And also, if you're not going to replace your glazing, it will be pretty difficult to achieve a overall UA of that alter space without, if you have single pane glazing, it's gonna bring your UA value up a lot. So it's that's kind of meant to consider, and then you'll have a lot of additional insulation. And I think, as Nick was mentioning, you don't want to just keep adding insulation without considering, condensation and other effects of your building. If you can go to the next slide. Other things that need to be considered is for both the prescriptive requirement of just the U factors, as well as the UA compliance in the component alternative pathway. The insulation values, they need to be derated between the studs, as well as accounting for any linear or point thermal bridges. And so while we've always had to derate between stud insulation, the new additional accounting for thermal breaks that is new in the stretch code. So, and all of these have to be taken into account before compliance. So on the graphic, it's kind of showing the, interruption to floor lines. That's something that we can't design around because it's an existing building. Where a new construction building, we can, add a thermal break there and mitigate some of that heat loss. But in an existing building, we have to work with what we have. So that's something that has to kind of be taken into consideration much more heavily. And then I think probably one of the more important ones, something that I've seen a lot in the chat, as well as others have mentioned, is the material integrity of these buildings. So if Laura, if you go to the next slide. So a lot of the building stock in this area, especially, we've got mass masonry buildings that currently operate by being able to, they have some capacity to take on water, but then they dry to the interior and exterior. As soon as we add interior insulation, it's inhibiting that drying to the interior, and it's then accumulating more water within the system. So it's really important, and we always push clients to take the time as early as possible in the design process to collect and then test masonry samples, and then use that for informing hygrothermal modeling, such as WFI, to assess the impacts of adding that interior insulation, whether that's from both increased risk of freeze thaw potential, and then also the risk of mold growth on those interior finishes, whether it's at the interior sheathing or somewhere within the insulation itself. One more. So this just shows that that inhibiting the drying to the interior. Yeah.
Thanks, Kim. That's super helpful. I know we're all of us working with existing buildings are looking at this, both residential and commercial at this point. And then we have Patrick to wrap us up with a few other existing building energy considerations. If that wasn't enough, if the stretch code wasn't enough, we know that there are numbers of other items to look at.
Thanks, Laura. So, navigating all of those and trying to figure out exactly where you fall on those decision trees, I don't want us to lose, the forest for the decision tree. And the forest is that we are trying to decarbonize all existing buildings. So within certainly Boston, roughly 3/4 of emissions in the city are related to existing buildings. And the code only applies to the buildings that are newly constructed or are renovated in any given year. And that's a small fraction of all of the existing buildings, within a jurisdiction. So, different municipalities have different policies in place, different types of policies requiring benchmarking of energy. And now through the Massachusetts climate bill passed last year, now there will be a state level benchmarking energy reporting requirement for large buildings. But then there's also energy auditing and emissions limits and clean power programs and the pilot program for fossil fuel bans. So there's a lot of other policy outside the code that you just need to check whether it applies to your local jurisdiction. I want to spend more time talking about Burdo in Boston and also Budo in Cambridge. And there's a proposal for a similar emissions limit in Newton. And what that is a relatively simple calculation of the emissions associated with your existing building, the gas consumption, plus the emissions associated with your electricity consumption. You can deduct any clean power that you procure or generate on site, and you have to be at or below a CO2 per square foot number. This is not a code requirement. This is something what every building you are designing now, every building you own that's over 20,000 square feet is subject to this policy, and you have to be at or below this emissions limit. So let's say that your building, is going through a repair or maintenance or a replacement of a water heater or something like that. Prescriptively, you may not need to electrify that piece of equipment, but you really should think about it and plan for it. So the reason is, like, you're trying to get the direct site emissions to zero if you can. Take advantage of the grid getting cleaner, install renewables if you can, all with the goal of reducing the CO2 per square foot of your existing building. When you touch that building or when you touch that piece of equipment, that is the prime time to make that investment to upgrade and to electrify and to improve the efficiency. Just because you don't have to necessarily, or just because the prescriptive requirement to upgrade, in kind might not force you to go to a heat pump, for example, doesn't mean you shouldn't, especially in jurisdictions like Cambridge and Boston that have these emissions limits. If you go next, Laura. So if we see that those emissions limits, the reason why I'm saying this is those limits go down over time to zero. So there are different types of or different levels of emissions limits based on different project types or occupancy types. There's higher limits for the high ventilation type buildings, the labs, the healthcare, et cetera, lower for multifamily or for office, but they all go to zero. And the only way to get there is to make the strategic investments in existing buildings to reduce their emissions, to electrify, to improve efficiency. And so just because you comply with the code does not mean you are going to comply with these laws. So let's look at an example. If you go next, the compliance paths within BERDO is one, operate below the emissions limits. That's the most straightforward way to approach it. Or there's an alternate compliance payment, or you purchase renewable electricity through municipal aggregation, renewable energy credits, power purchase agreements. But the goal, I think, is just to operate below those emissions limits. If you go next. So looking at an example, and this is a life science project, but it really, the philosophy applies to most any. So this is either a new construction or a major renovation. Comparing a typical building that may be able to get away with, or was up until this code able to get away with, using fossil fuel for a lot of the heating. You see in the blue bar the amount of emissions associated with gas versus the amount of emissions associated with electricity in the lighter blue. Compare that to a high performance building that electrifies at least most of, if not all of, its heating loads. And so the emissions are lower, and primarily that's because the gas emissions are lower. And they're certainly below the BERDO limit. A well-designed new building or renovation can be well below the initial BERDO limit. That sounds great, but we're talking about every existing building, every new building, every renovated building is an existing building under these laws, over 20,000 square feet. So let's look at the next 5 years. Next. That BERDO limit's coming down fast. The grid is not getting cleaner as quickly. So all of a sudden, the traditional approach, if you had just replaced the gas boiler in kind, for example, you're already exceeding that limit. Whereas if you make the investment to improve efficiency and to electrify, you can stay below that limit. And then we see that kind of play out in an exacerbated fashion over the next several years. We go next. So, just because you are complying with the code does not mean you're complying with all of these other types of provisions. That's really the message here, to think big picture about investing in your building and making sure that when you touch the building, when you renovate the building, or you renovate a portion of a building, or you alter something, that you're doing it in the big picture and not just trying to check boxes on the code.
Thank you, Patrick, and thank you to everyone speaking. I really appreciate there's so much information here, and I always learn while I'm speaking with you all or working through this. And also really impressed, we kept it in our hour. So well done, everyone. And it gives us about a half an hour to answer questions. I know there have been a number of them in the chat. And we really appreciate that. I think people have been able to answer as we go. I do want to say, we have these great resources, and we will share out the slide deck. Once again, if please feel free to reach out to myself or other presenters on to get this. The video itself will be up on the BSA COTE website, and it will give BSA a few days to get it up there, for folks, but please share that resource out. And then just as a reminder, we will be having this as a series. This is a discussion. We know we're all working through it, and we next month at about the same towards the end of the month in April, we will have a discussion on TEDI. And if you aren't familiar with TEDI yet, it is coming, and we will have a lot of folks that are digging into it. So now I will stop sharing, and if folks want to unmute and ask their question, that would be fine with me. I see Andrew's top on my screen if you want to unmute and ask.
Thank you, Laura. I did post a question in the chat that didn't get answered. Could someone explain to me how R403.6 residential mechanical ventilation is going to work? I go through residential houses all the time, and many of these do not have a continuously operating mechanical balanced ventilation system. And I don't think I've ever encountered a house just in suburbia here that has an HRV or an ERV. So I can't figure out how to explain to my clients right now whether their projects are going to trigger that their whole house now needs to have this. We need to provide this just in their additions or their unconditioned space being converted to conditioned space. I can't for the life of me figure out what this provision means.
So I'm going to say, Patrick, I don't know if you can weigh in on any of that, or if I know I see Jacob, who was part of our overview on here. You're welcome to jump into if you have anything to add.
So that
Sorry,
was a
I was catching up on the
residential.
chat then.
That was a residential question.
Correct. Residential code section R403.6 mechanical ventilation, and then the subset R403.6.1 regarding heat or energy recovery ventilation.
Ian actually is on the phone, has his hand up from the DOER.
Sorry, I didn't see you there. Ian, please, yeah, if you could, I didn't, sorry.
Yeah,
thank you, Lauren.
I'm happy to take that question if you want. So Andrew, is your question about additions or alterations, or?
Yes, new construction, not a problem. Happy to provide these things. But if I go into a house that has, again, radiators, they don't even have ductwork around the house.
Yeah.
There's nothing to piggyback off of. And even if there is an existing forced hot air system, that doesn't mean we have HRVs, ERVs, anything like that in place. So do we need to provide these only in things like the additions or the newly conditioned space? Or do I have to upgrade the whole house? And again, maybe that's that 1,000 square feet of conditioned floor area trigger, but I can't find how it's intended to be used.
Yeah, so the good news for you is it's not a requirement. And that's why in that flowchart, it's pointing to the table in the HERS rating pathway, not the whole pathway. So it's get a HERS rating under compliant with the table in R406.5. It's not follow the entire pathway. If you had to follow the entire pathway, then you'd have to have an HRV or ERV and balanced ventilation. But you may choose to use that strategy to get to the HERS rating that you need for the dwelling unit that you're testing, but it's not a requirement.
Yeah, that was, oh, sorry.
I was just going to ask if
because when I read
that
the
makes
base
sense.
code, when I read the base code requirement, it looks like we had in Massachusetts deleted the first part of the sentence that had to do with buildings and dwelling units shall be provided with mechanical ventilation that complies with the requirements of the IRC or IMC as applicable, or other approved means of ventilation. Our code starts with the next sentence, outdoor air intakes, and then says each dwelling unit shall be provided with. I don't see any ambiguity there. It suggests to me that we have to comply.
You have to comply in new construction. If you're putting in a new ventilation system in an addition or an alteration, then I think we'd want that new system to comply. But there's nothing that sends you back to the existing space.
Okay. And if we cross that 1,000 square feet of conditioned floor area, should I assume that we're going to then be pulling that into?
So no, if you
No.
cross that area, you're treating the addition and a new system in the addition as a new system. But you don't have to retrofit the existing ventilation to the extent that there is any existing ventilation.
Exactly. Okay.
Yeah, so we understand that's an issue. And so that's why it's not sending you to the full pathway, it's just sending you to the HERS table requirement.
And
Okay.
we had discussed that also with Ian when we had done these decision trees to make that distinct so that it was bringing you to that table R4 06.5 and the HERS and not the entire R406 pathway. So that that's a good point.
Thank you.
Next question.
Yeah. Julia, it looks like you're next on my screen with your hand raised if you want to.
Great, thank you. Thank you for this. It's a lot to try to digest, but I appreciate this opportunity. I had a question about the 1,000 square feet. Well, actually 2 questions, but I'll start with that one. The 1,000 square feet and then how it relates to the 100% of the building. We had a quick lunch and learn in our office where it made it sound like if it's more than 1,000 square feet, you have to like everything has to comply, which I'm glad that doesn't sound like that here. But it's relative to the square feet in the existing building. Is that true? So if you have a building that's, 4,000 square feet, then your 1,000 square foot addition may not fully trigger I don't know if I'm asking that correctly.
If I'm understanding correctly, you're saying, if you go over 1,000 square feet in an addition to a residential, does that trigger upgrading everything?
Right, because there's also that 100% of the building portion of the code.
Lauren, I know you did that portion of the decision tree. Would
Yeah.
you like?
I don't know if Ian though, I feel like I'm going to kick it to Ian. I mean, I can answer it, but I'll let Ian.
I'm sure Lauren and I would say the same thing, but I can answer if you want. Yeah, so for additions, it's clear cut. 1,000 square feet is your only test.
Okay.
And what's triggered after 1,000 square feet is a HERS rating on the dwelling unit. Now, if the addition contains a dwelling unit, if you're putting an in-law apartment in, for example, then you can do the HERS rating just on that space. But if the addition is just expanding the size of the existing dwelling unit, then you do a HERS rating on the whole dwelling unit. Again, it's just the HERS rating that's required. So if you don't want to change the mechanical ventilation system in the whole house, you don't need to, but you're going to need a pretty comprehensive set of strategies to get that whole dwelling unit HERS rating point. And Chris or Bijan or others or Nick can weigh in on what the preferred strategies are to get there. If it's an alteration, then the size of the existing house is critically important, because if you have a 4,000 square foot house, you can alter up to 2,000 square feet without triggering the 50% threshold of a level 3 or an extensive alteration. So you can renovate 1,800 square feet and not trigger the HERS rating requirement.
Ian, though, part of our question on the decision tree, though, for the addition is the addition to a dwelling unit greater than or equal to 1,000 square feet, or does it exceed the existing conditioned floor area? So,
Yeah.
so
Oh,
I
yeah.
think,
So on that, the intent there is really for projects in small cottages or small houses.
Mhm.
So if you have a unit that is only 650 square feet today, and you add 800 square feet to that, that wouldn't hit the 1,000 square foot trigger. But we think if you're adding that much of a percentage that you're over 100% of the original conditioned floor area, then that should trigger the HERS rating requirement. And that should be relatively straightforward compared to a lot of other projects, because your new floor area is, larger than your original floor area. And again, that's to kind of address situations where typically where developers are coming in, buying small affordable properties and turning them into much larger properties. We felt like that was an appropriate place to put that HERS requirement in.
Thank you.
So it looks like Bijan. I'm sorry if I'm
Yes.
saying.
Thank you.
Hi.
Yes, my question is actually for Ian, and it's related to this gray area, I call it, that we are in between January 1st and July 1st, when it comes to the mid-rise and high-rise situation residentials. So, and as we know, the old stretch code was HERS rating was mandatory 4-story and below. And let me try to make this simple. First question about the definition of number of stories. We work with Mass Safe, and we are trying to potentially change that definition when it comes to residential. My question for Ian is, I'm sorry, Ian, that for residential multifamilies, when we talk about number of stories, let's say if we have an open garage on the ground level, and then retail on the next level, and then 3-story residential above it. Are we still calling this a 5-story building or 3-story residential?
Okay, hi, Bijan. Thanks for that question. So in my mind, that's not a Massachusetts question. That's an ICC question, right? How do you define how many stories is in a building is not something that's unique to our code. So I would say I defer to the ICC guidance on that. But my understanding, so I'm not the authority on this, but my understanding on this is if you have an unconditioned open garage that's taking up a story, then that's maybe not going to count to your stories above grade for whether you're in the IRC or not. And that's your key question, right? You want to know, is your multifamily covered by the IRC? Because if it is, then it's covered by the residential stretch code. Now, if it's not, then you're in the commercial code for until July 1st. That said, a mixed use building like that, I think you have, and you can ask the authority having jurisdiction, I think you have a good case for saying that automatically triggers the commercial code, and then you can follow the commercial code. But then you do have this 4 stories or below has to follow residential. So, I mean, it has to get a HERS rating, I guess.
Yeah.
So I can't give you a definitive answer, but that's how I would go about it.
No, I got my answer. Thank you, Ian. Just quickly, after July 1st, I understand that we can do HERS rating on any number of stories, 5, 6 stories, 7 stories, etc. But the question is, between January 1st and July 1st, the 4 stories, right now they're in the gray area. So is that, first of all, is no longer mandated to do 4-story HERS rating? And If not, is there an option? So prior to January 1st, 4-story was mandatory, 5-story was optional, 6-story was not an option to do HERS rating. Between January 1st and July 1st, is 4 and 5-story, what happens to them?
Yeah, until January 1st, the stretch code of last year still applies. So I don't think anything has changed there.
Not until July 1st, you're saying? So
Yeah, not
right now,
until July 1st, and then it changes.
okay. Thank you. Thank you.
Thank you. Jeff, I think your hand is the hand raised next.
Hi, thank you. For alterations to existing buildings, I understand the lighting portion is prescriptive and mandatory. It's not something that's modeled. Is that correct?
Sunny, are you able to answer that? I know that was part of your.
Sorry, I was answering a question on the chat. Can you repeat the question, please?
Oh, for alterations to existing buildings,
Mhm.
I understand the lighting portion is mandatory and prescriptive. It's not modeled. Is that right?
Yeah, the intent for existing buildings is that you wouldn't need to do any sort of energy modeling unless you choose the 2 optional compliance paths, which are envelope related. Does that answer your question?
Okay. Yes, thank you.
There are a number of questions in the chat, and we will, as I said, have this available both in video and if you like the actual hard copy. We'll take the chat and put that into the presentation that we'll hand out so that the answers will be documented in there. Are there any other questions? We have a little more time. Oh, Amy.
Oh, hi everyone. Thanks for this great presentation. I have what maybe a silly question, but if we have a residential, this is a residential question, existing building, we are starting to do some pre-tests on buildings just to say what's the leakiness of our existing buildings of a New England house. We're finding existing houses, whether they be 1980 or 1800, might even be up around 9 or 10 ACH. And so my question is, if for our HERS certification, if that is our compliance when we do a renovation, how say they are sharing airspace and it's not a separate in-law apartment. Are we testing, this is a question, I guess the HERS raters or Ian, are we testing the full building, or is there a thought that you would try and seal off an addition? Just want to understand that.
I can start, but then I defer to HERS raters if they want to chime in. You can only really do a HERS rating on a complete dwelling unit. So, so you might want to test the air leakage on your addition to know what the air leakage is on your addition, but it's not going to be your compliance blower door test. Your blower door, and there's no limit in the HERS rating on what your air leakage rate is, obviously, but it is a big factor in getting down to 52 or 55 or 58. So yeah, if your project is going to trigger that HERS rating, it is going to require serious thought to air leakage mitigation in the older portion of the building. And I mean, it's something that we're interested in getting data on. If we're finding that that's really difficult to get to the low 50s, then there's a potential we could have a code change proposal that increases that HERS rating level. Or another idea that we're mulling at the moment is having a sort of embodied carbon credit that gives you a bonus on the HERS rating for preserving the existing building. But in order to pick the right level, what's the right HERS rating? It's going to vary dramatically across the range of existing building projects. And so we would like to get more data on that. And we do have an MOU with ResNet. So we do see all of the final HERS ratings in Massachusetts. It's one way that we keep tabs on compliance in different municipalities. So we should be able to get some data on that way. But if you want to help us with that, that would be terrific.
Chris, I don't know if you want to weigh in as well, from your experience.
Yeah, sure. So typically with renovations and additions, we tie it into there's a combination. There's a building code requirement, but then there's also a fairly robust mass save incentive program for renovations and additions. And in that program, we would do a blower door on the existing house, and then a blower door on the finished product house. And that incentive is based really on the difference between the two. It's the kilowatt savings between the two, the BTU savings between the two. So we would do a blower door on that final product. And the assumption is that in most cases, most buildings do start off at least 10.2 air changes per hour. And the expectation is that we would get the finished product, the finished building, with strategic weatherization down to somewhere under 5, hopefully close to 3 ACH. That's typically where we try to aim. And it's not that hard. It really isn't that hard to do.
Great, thank you. If anyone else, we've got a few more minutes. Oh, Lauren.
Yeah, so I've been seeing all the great questions in the chat, and actually I wanted just to highlight one that Diane had posed. She posed she made a couple good points. One is saying that the DOER in the technical guidance recommends that projects reach out to the authority having jurisdiction for their projects to discuss the applicable code, what they think is the applicable code pathway with them. And another is, I think she brought up, is that having a centralized location for some of these things like the decision tree and where that all could live, whether it's the BSA or I don't know, but just so it's, having that kind of one location that could help everyone find it might be helpful.
Yeah, we are happy to try to facilitate it going on the BSA. It's hard to put the more than just the videos up, and so, but we'll try to find a better way to do this. I don't know. It's definitely hard. There's so many different groups and so many different people, but just for now, folks, please feel free to reach out to myself or Allison or any, I'm sure most folks on the talk would be happy to help, but
yeah, for sure.
Hopefully it is a great comment. I just,
Yeah, no, I didn't mean to put anyone on the spot.
No.
It's that, I think there's, we can look at it beyond, but yeah.
Well, if there's I see no other hand raised, and I want to thank everyone who presented and all of you for attending. We really appreciate everyone's interest in this. And as I said, the TEDdy discussion will be next, which will be very exciting. I'm looking forward to that. And please check back on the BSA site to see when that will be listed. And if you registered for this through the BSA, we've been trying to send out the next in the series to that list group. So hopefully you'll get a notice. Thank you again to the presenters, and everyone have a very nice Friday and hopefully a good weekend.
Thank you.